What's up guys, this is Masi. Welcome to another video. In this video I want to show you how to solve acceleration questions in kinematics. I have different examples here. This is the first question. It says the position of the particle moving along an x-axis is given by x equals to 12t squared minus 2t cubed, where x is in meters and t is in seconds. Determine A, the position, B, the velocity, C, the acceleration of the particle at time equals to 3 seconds. So let's start these three parts first. So in order to find out the position, we just need to sub the time in here. So it's going to be x equals to 12 times 3 to the power of 2 minus 2 times 3 to the power of 3. That will be 54 meters. Part B, it says find out the velocity. Velocity is going to be the first derivative of x. So that will be 24t minus 6t squared. So V will be 24 times 3 minus 6 times 3 squared. So it's going to be 72 minus 54. That's going to be 18 meters per second. Part C, we need to find out the acceleration. Acceleration is first derivative of velocity or second derivative of distance. So that will be 24 minus 12t. When you sub 3 in here, it's going to be 24 minus 36, and that will be negative 12 meters per second squared. In part D, it says, what is the maximum positive coordinate reached by the particle? When we are talking about maximum x, it means that we have critical point. It means that the velocity is 0. So the formula for velocity is this guy. So it's going to be 24t minus 6t squared equals to 0. So it means that 24t equals to 6t squared. When you simplify it, t will be equal to 24 divided by 6, which is going to be 4 seconds. So that's basically is going to be the part E answer. And because it says what time is it reached, and we need to find out the x as well. How to find it? We just sub it back to the original equation. It's going to be 12 times 4 squared minus 2 times 4 to the power of, it's going to be 64 meter. Now we need to find out the part F. Part F, it says what is the maximum positive velocity reached by the particle and at what time it reached. When it says maximum velocity, it means that the acceleration must be 0. So acceleration must be 0. The formula for acceleration, we have it here. It means that 24 minus 12t equals to 0. It means that 12t equals to 24. So it means that t equals to 2 seconds. And it says that at what maximum velocity, so we get this 2 here, we sub it in the formula for velocity. So velocity will be 24 times 2 minus 6 times 2 to the power of 2. That's going to be 48 minus 24. That's going to be 24 meters per second. That's the maximum velocity. Part G, it says what time is reached. We actually answer to this question too. It's going to be t equals to 2 seconds. Let's do part H. Part H says what is the acceleration of the particle at the instant the particle is not moving. So it means that when x equals to 0, what is going to be the value of time? So it's going to be 0 equals to 12t squared minus 2t cubed. It's going to be 12t squared equals to 2t cubed. When you simplify, it's going to be 12 equals to 2t. So t will be 12 divided by 2, which is going to be 6 seconds. Actually, it says when it is not moving. When it says not moving, it means that v is 0. So we can say that 24t equals to 6t squared. T will be 24 divided by 6. It's going to be 4 seconds, not 6 seconds. So that's the answer to part H. And finally, part I is saying that what's the average velocity? So average velocity is going to be change in x divided by change in time. So at time equals to 3, x was 54. At time equals to 0, it was 0 divided by 3 minus 0. So 54 divided by 3 is going to be 18 meters per second. So that's the final answer to this question. In next question, we have at a certain time, a particle had a speed of 18 meters per second in the positive x direction, and 2.4 seconds later, its speed was 30 meters per second in the opposite direction. What is the average acceleration of this particle during this 2.4 seconds interval? We know the average acceleration is going to be the change in velocity divided by change in time, which will be velocity at t2 minus velocity at t1 divided by t2 minus t1. So the velocity at t2 is negative 30 meters per second minus v at t1 is going to be (18 meters per second) divided by 2.4 minus 0. So it's going to be negative 48 divided by 2.4. That will be negative 20 meters per centimeter squared. So that's the acceleration. So the acceleration is negative and the magnitude is 20 meters per second squared. It is in opposite direction. That makes sense because the velocity of particle is decreasing over time. So we can have a function for velocity. Velocity equals to initial velocity plus acceleration times t. So we can say v equals to 18 minus 20 t. So we can write an expression for velocity like this formula. In this example, it says if a position of a particle is given by x equals to 20t minus 5t cubed, where x is in meters and t is in seconds, when, if ever, is the particle's velocity 0. So we know velocity is the first derivative of x with respect to t. So when we get the derivative of this one, it's going to be 20 minus 15t squared. So since it's going to be 0, I need to make it equals to 0. Therefore, it's going to be 15t squared equals to 20. So t squared is going to be 20 divided by 15, which is going to be t equals to plus minus square root of, when we reduce it, is going to be 4 over 3. And the answer is going to be, the negative is not acceptable because we don't have negative number, and it's going to be 1.2 seconds. So at t equals to 1.2, velocity will be 0. Here in part B it says, when is its acceleration 0? Acceleration is the first derivative of velocity over time, or the second derivative of x. So we need to get another derivative of this guy. The derivative of 20 is going to be 0, and the derivative of this part is going to be negative 30t. So acceleration has to be 0. It means that only at time equals to 0 the acceleration is 0. Part C, it says for what time range positive or negative is a negative. So we can say that a as a function of time equals to negative 30t. That can't be positive at all, because when time is positive, a is gonna be negative. And we cannot have negative numbers for time, so we can say for all time greater than 0, acceleration is negative. Part D, it says when it is positive. Basically, it cannot be positive. Why? Because in order to be positive, we need to have negative numbers for time. And it's not possible to have negative numbers for time. This question says from time equals to 0 to time 5 minutes, a man stands still, and from 5 minutes to 10 minutes, he walks briskly in a straight line at a constant speed of 2.2 meters per second. What are, part A, his average velocity, part B, his average acceleration, in the time interval 2 minutes to 8 minutes? So let's do part A and B first. It says from time equals to 2 minutes to time equals to 8 minutes. We know up to 5 minutes the man was not moving, but from 5 minutes to 8 minutes it was moving. So 8 minus 5 is going to be 3 minutes, and when you convert it to seconds, it's going to be 3 times 60, 180 seconds, or 180 s. So the distance is going to be 2.2 times time. Why 2.2? Because the velocity is 2.2 meters per second. So when we multiply it by 180 seconds, it's going to be 396 meters. So the velocity is going to be the change in distance, which is 396 minus 0, divided by 8 minus 2, which is 6 minutes, and 6 minutes is going to be equivalent to 360 seconds. So 396 divided by 360 seconds is going to be 1.10 meters per second. Part B, it says find out the average acceleration. It's going to be change in velocity. So it was basically 0 right from the beginning. So we have 0 in this case. And it says time 8 minutes, we have 2.2 meters per second, divided by, again, 360 seconds. So 2.2 divided by 360 is going to be 0.00611 meters per second squared. Now this time in part C, it says what are V average velocity, and average acceleration in the interval of 3 minutes to 9 minutes. So from 3 minutes to 9 minutes, we have 6 minutes again, which is 360 seconds. So average velocity is going to be again x2 minus x1 divided by t2 minus t1. x2 will be velocity times time. The velocity was 0 till 5 minutes, and then from 5 minutes to 9 minutes we have 4 minutes, so 2.2 meters per second times 4 minutes. When you convert it to second, it's going to be 240. That's going to make it 528 meters. So it's going to be 528 minus 0 divided by t2 minus t1, which is going to be 360 seconds. That's going to make it 1.47 almost meters per second. That's the average velocity. And if you want to find average acceleration is going to be again 2.2, the secondary velocity, divided by minus initial velocity, which is 0, divided by again 360. So again we have 0.009611 meters per second square. So as you see here, the acceleration here and here is going to be the same. It depends on the initial and final velocity, and also depends on the time as well. In this question, it says the position of the particle moving along the x-axis depends on the time according to the equation x equals to ct squared minus bt cubed, where x is in meters and t in seconds. What are the units of a constant c and b constants b? So the answer to a and b is going to be, so we have this formula, x equals to ct squared minus bt cubed. So all of them must be in terms of length. So when ct cube is in terms of length and ct squared, and bt cube is going to be in terms of length. So therefore you can say c is going to be in terms of length divided by time squared, and b is going to be length divided by time cube. Then in part C it says, at what time does the particle reach its maximum positive x position? When the particle reaches its maximum or its minimum, it means that the velocity is 0. Velocity is the first derivative of x with respect to t. So we need to find out the first derivative. That will be 2ct minus 3bt squared, and that has to be equal to 0. So it means that 2ct equals to 3bt squared, and it means that t will be 2c divided by 3b. And it says when the units are 3 and 2, just sub it there. So it's going to be 2 times 3 divided by 3 times 2. That makes it equals to 1 second. So that's the answer to part C. In part D, it says what distance does the particle move? So it's going to be x equals to ct squared minus bt cubed from t equals to 0 to t equals to 4. So basically we're going to say that x equals to 3 times, the t has to be 4 squared minus 2 times t 4 cubed. It's going to be 48 minus 128. That makes it negative 80 meters. That's for time equals to 4. At time equals to 0, x is going to be 0. And we know at time equals to 1, it goes to the maximum number. So we have x equals to 3 times 1 squared minus 2 1 cube, which is going to be 3 minus 2, and it's equals to 1. So it moves from 0 to 1, and then from 1 to negative 80. So the total path length is going to be 1 plus 1 plus 80, which is going to be 82 meters. So that's going to be the distance it traveled. What about the displacement? Displacement is going to be just negative 80. Why? Because at time 0, the x was 0, and at time equals to 4 minutes, it is negative 80. As you remember, the displacement and distance are going to be two different concepts, and distance doesn't have any direction. Part F. It says find out the velocity at different time. The velocity, we got the equation in here. I'm going to write it again. is going to be 2c, which is 3t minus 3 times 2t squared, which is going to be 6t minus 6t squared. So that will be v at 1 is going to be 6 minus 6. That's going to be 0. G is going to be at 2. 6 times 2 minus 6 times 2 squared. It's going to be 12 minus 24. That's going to be negative 12 meters squared. H is going to be when time is 3 seconds. 6 times 3 minus 6 times 3 squared. It's going to be 18 minus 54, which is going to be negative 36 meters per second. I is going to be when 4 seconds. It's going to be 6 times 4 minus 6 times 4 squared. That will be negative 72 meters per second. And in part J, we need to find out the acceleration. It's going to be the derivative of velocity function is going to be 6 minus 12t. The first one, J, when you sub 1, is going to be 6 minus 12. This is going to be negative 6 meters per second squared. K is going to be 6 minus 24, which is going to be negative 18 meters per second squared. L is going to be 6 minus 12 times 3, which is 6 minus 36. It's going to be negative 30 meters per second squared. And finally, M is going to be 6 minus 12 times 4, which is 6 minus 48. That's going to be negative 42 meters per second squared. So this is the final answer. I hope you enjoyed this video. I tried to have different examples for finding acceleration. Please leave me a comment if you have any question and I'll get back to you as soon as possible. Thank you for watching and have a great day.